Hello everyone, welcome back to Pre-Algebra with Miss Betsy. We're about to resume with our fifth lesson. This is section 1.5, which is entitled Translating Word Phrases. You find this in Pre-Algebra for Christian Schools, Bob Jones University Press. You can use any text when you're doing this. We've got our lame joke for the day. I have my notes over here to remind me. I see a glare on the board, but the question is, we have these three fractions here. AC, WC, XC, A over C, WC, XC. And the question is, how do we know that all three of these fractions are in Europe? I'm speaking from America. Well, we know that AC, WC, and XC are all in Europe because all of them are over C's. Boo, groan, hiss. All of them are overseas. What you have that's good for you since you're watching these videos at home on YouTube. You don't have to be up early in the morning like at 9 o'clock or 8 o'clock in class listening to this live and saying, oh goodness, that is a bad one. Anyway, we're going to go ahead right on with our lesson, translating word phrases. And what I've mentioned to you before, and what you already know, is that a whole lot of what you have to conquer in math is simply learning the vocabulary. There's their own definitions that are involved with algebra, and there's also their own ways of writing things. You have to be able to take English words, and actually I could have not even put the 9 here. We're going to take our English words that would say 9 decreased by 5. And let me change this one here to a number increased by, let's just say 12. Now if you look at that, that's clearly written in English. English words. There's no pluses or equals or anything in there that lets us translate this into a mathematical statement or a mathematical expression. So in order to be able to do things algebraically, you have to go from English to algebra. So what do we have that we're looking at? Well, 9 decreased by 5. You already know that you have a symbol that represents the English word 9, and it looks like this. It's number 9. The English word 5 is represented with the Arabic numeral that looks just like that. Now, what English words do we have that we need to translate into algebra or into the language of mathematics? And that would be decreased by. Now, what do you think of when you think of decreasing something? If the amount of pizza on your plate decreases, do you have more of it? Do you have now a great big huge stack of pizza on your plate? No, well, it's getting smaller. So decreased by is talking about shrinking. Now, what mathematical operations do we have? Well, we have multiplication, which makes something bigger. We have division, which separates, divides, chops stuff into a bunch of different equally sized parts. We have addition, which increases the size. And we have subtraction. Well, yeah, of course. 9 decreased by 5. Decreased by is referring to subtraction, so we use a subtraction symbol. 9 decreased by 5 in English is simply 9 minus 5. So when you see decreased, less than, words where something is shrinking, you're going to be dealing with the operation of subtraction. This next one right here, a number increased by 12. Well, what happens if you have a number of M&Ms in your hand? You have 3 M&Ms, and it's increased by 12. How many M&Ms do you end up with? Yeah, of course, you end up with 15 M&Ms because you started with 3 M&Ms. They increased that number by 5, or they gave you, Mom gave you 12 more M&Ms, so you had 12. You had the 3 plus 5. I'm speaking backwards here. You had the 3 plus 12, and you ended up with 15 M&Ms in your hand. So you had some number at the beginning, which in my illustration I used to be 3. You added 12 to it. But this doesn't tell us that we had 3 M&Ms. It says we just had a number, some random number. And that's where you get algebra from. We don't know what that number is, so we use what I've told you about, what you've learned already is a variable. It's just a letter that can be used to represent any number that you want it to. Now, a lot of times in beginning algebra classes, they'll say if it says a number, we're going to, well, what letter do I want to use? I can use X, I can use A, I can use Q. You can use any letter you want to for the variable, but a lot of times it makes it easier for kids to like maybe take the first letter of what we're talking about. Here, we've got a number. Let's just have n represent this number. N increased by, we said that's addition, so we have n plus, the number is n, increased by is addition, and of course you know the Arabic numeral for the word 12 is just 12. So what we have done here is we have shown easy translation from English words into an arithmetic sentence. English words into something that is now just, this was arithmetic, we've actually got algebra because we have variables in here. So when something's increased and you're translating from English into arithmetic, it's going to be addition. When it's decreased and when it's made less, when it's reduced, it's going to be talking about subtraction. Multiplied, well obviously that is, you're multiplying. If we said 9 multiplied by 5, every single one of you would say, oh, that's easy, 9 multiplied by 5 is 45. You wouldn't even have to think about the fact that you had translated from English into arithmetic. So that's what this section in your homework is all about. There's one thing that I want to talk about real briefly. Remember we said earlier, we talked about the commutative property. And what's a commutative property? That says that the order in which you perform two operations doesn't change the outcome. So if you had 2 plus 3, that answer of course is 5. Let's say, well, we want the order to be different here. What if we change this order around? 3 plus 2, the answer is still 5, correct? Well, yeah. And what happens if we use multiplication? 2 times 3 is 6. We switch the order around, and the answers are still the same. Addition and multiplication are commutative. It doesn't matter which you put first. But what happens if we have 2 plus 3? I didn't mean that. Let me do it this way. What if we have 3 minus 2? I have 3 cookies. I eat 2 of them. I have 1 cookie left. Let's turn that problem around. Instead of saying 3 minus 2, what if we said 2 minus 3? I have 2 cookies. Can I even eat 3? No, you can't even really eat them. So you have to go into saying, using negative numbers. So these two illustrations here, 3 minus 2 is a positive 1, 2 minus 3 is negative 1. You don't get the same answers, so order matters in subtraction. They are not commutative. And the same thing for division. Let me see if I have 4 divided by 2. 4 divided by 2 is 2. However, 2 divided by 4 can be written as 2 over 4, which is a fraction that reduces to 1/2. So when you change the order around with subtraction, with division, you get a different answer, so those are not commutative. So when you're translating from English to the language of math, you have to be very, very specific about the order in which you do things. Let me show you this exact illustration from your book. It says in examples 1 and 2, I'm on page 19. The order in the mathematical expression is identical to the order found in the word phrase. Sometimes you must reverse the order to make the expression mathematically correct. What they were talking about was this first sentence I had here that said 9 decreased by 5, and we did 9 minus 5. And then we had a number increased by 12, and it was a number n increased by plus 12. 12, so the math sentence was in the same order as the arithmetic sentence. Doesn't always happen. Here's one that we have. 8 more than a number. Okay? 8 more than a number. Let's think about this. What are we comparing the final number to? Are we comparing it to 8, or are we comparing it with a number? What are we starting up with? Well, we're starting with a number, which we're going to say is n, and then we're saying 8 more than this number. How do you do more than? If something is more than, you've added to it, haven't you? So you have this number n that you started with. 8 more than that means that you add 8. So this right here is the technically correct, if you will, translation from the English into the algebra. Now, I just illustrated to you that order doesn't matter in addition. So addition is commutative. So you could also write this as 8 plus n, because it means the same thing, n plus 8, 8 plus n, you get the same result. But I really, really, really don't want you to do it this way, even though it means the same thing, because I want you to be ingraining in your mind the idea of actually writing, actually doing a very literal translation here. 8 more than a number. Think of what are you starting with first, what operation is being performed on it. So what we're starting with first here is a number, and our result is going to be 8 more than that number. And I don't know if this will help you. It helps some kids. It helps me with my crazy brain. When I have more than or less than, I sort of write it backwards. And if this helps you take it, if it makes no sense, just completely ignore it. We have, let me just do that same one. 8 more than a number. 8 more than a number. I write from right to left, which obviously is not the correct way to write, and we're not speaking Hebrew, we're not using Hebrew with our arithmetic. But this takes, by writing it backwards, I'm putting it in its natural order, because it's sort of spoken backwards here, because we're starting with the number. So if this is the beginning, this is the end. 8 more than a number. What did we start with? We started with a number. We have 8 more than it. I'll just show you this. If it clicks with your brain, use it. If not, ignore it. Okay, the next one that I want to illustrate is a number less than 9. Okay, first off, let us think. I want you, give me a number that's less than 9. Well, okay, 8. 3 minus 500. Is 10 a number less than 9? No. Well, how am I getting to, how did I go from 9 to like a 2? I had to subtract 2 from 9, didn't I? So this is another one that is backwards. A number less than 9. You have to look at the sentence and say, what am I starting with? What quantity am I beginning with? I'm starting with a 9, and I'm coming up with a number, n, that is less than 9. 9 minus n. Now, I told you that you could do 9 plus n, n plus 9. That addition, the order doesn't matter, even though I really want you to be very specific about what you write. So what I have here is 9 less than a number. What if this were can I switch it around and say 9 minus n? Well, you may be thinking, yeah, Miss Betsy, I don't see a whole lot of difference in that. Well, let me illustrate the difference. Let's just say that for our purposes, we're going to say n is equal to 3. So we have 9 minus 3, we have 3 minus 9. 9 minus 3 is positive 6, 3 minus 9 is negative 6. Subtraction, remember, is not commutative, so you have to be very, very careful with subtraction numbers. Once again, if you write this backwards, a number less than 9, you have your algebraic statement in correct order. Some of you, you're going to like to do it that way, it makes sense, some of you don't. So be very careful with the order as you're translating things. Now, let's think about these words I'm going to have here. Is it addition? Is it subtraction? What if we talk about the sum of? What is sum? Sum is the answer to an addition problem, so sum of means you're going to put addition in. Increased by, you start with something, to increase it, you add to it, so it has to be addition. What happens with plus? Well, obviously it's not a division sign, your plus is addition, we all know that. What is the difference of? This is vocabulary. Difference. Difference is the answer to a subtraction problem. So let me just review this right quickly for you. If you have 2 plus 3 is equal to 5, these are called addends. The numbers which you are adding together are addends. The answer is called the sum in an addition problem. If you do not know this, write it down and learn it for next time. Now, if you have subtraction, 3 minus 1 is 2, the answer to a subtraction problem is what? It's the difference. Now, in algebra, you very rarely use these words, minuend, subtrahend. What's the reason? I mean, why do they come up with weird names like minuend and subtrahend? It just sounds really impressive. You say, oh, the minuend and the subtrahend, when you interact those two together, you end up with a difference. And you're going, excuse me? And then somebody steps in and says, oh, all he's saying is say 3 minus 2 is equal to 1. 3 minus 1 is equal to 2. So minuend is the number that you begin with in a subtraction problem. The subtrahend is the number that you're taking away. The solution is the difference. These two right here rarely show up. They're not a big deal. Addend, sum, difference. What else do we have? Well, we have multiplication and division. What's this vocabulary? Okay, that's right. When you have multiplication, 2 times 3 is equal to 6. The things that you multiply together, these are called factors. You must understand what factors are. And the solution to a multiplication problem is called a product. You will see factor and product constantly in math from now on. So you have to know that factor means those are all the little numbers, the letters, the fractions, whatever, that you're going to multiply together. And that they call your answer the product. And you also have to have this down. You have a division problem. You have 4 divided by 2 is 2. This is the way that you've been doing division most likely up to now. You know, the little house thing with the guy on the roof. Well, you're not going to be doing division like this anymore unless you're hand calculating something and you want to say, okay, what is 186 divided by 3? 3 times 5, 3 times 6 is 18. Bring down the 6, 2. That's going to be the only time that you're using division, long division like that. Rather, you're going to write this division problem as a fraction. So it's going to be 4 over 2 is equal to 2. Two different ways to show the same problem, but what I'm keying in here that you need to get is the vocabulary. The number that you have underneath the house, this is the dividend. This is the divisor. And this is the quotient. You absolutely must be able to identify these things because you'll have difficulty with algebra if you don't, because it shows up all the time. If it's set up like a fraction, the numerator, the number on the top, is the dividend. The number by which you are dividing is called the divisor. The solution to that problem is called the quotient. So make sure you've got all that vocabulary down, relearn it, learn it for the first time, or just say, oops, I already know that. So you don't have the vocabulary from there. Now let me pick a couple of examples to go over right quickly from our book. I can go ahead and erase this. See, I'm going to go ahead and pick number 8. It's the difference of 15 and 10. The difference of 15 and 10. What's the key word in that problem? Well, obviously we have to use the 15 and the 10, but they're talking about difference. What operation does difference belong to? Well, yeah, it's subtracting. The difference of 15 and 10. When they have a problem like this that involves subtraction, the order is important here. So it's the difference of 15 and 10. That's just 15 minus 10. It's not like minus 15 plus 10 because it says and here. And that's something to be careful about, because sometimes when they say and, they'll say 2 and 3 makes what? It equals 5, so it's talking about addition. But here it's just saying these two numbers that we are comparing, we are finding their difference. So it's a simple subtraction problem. Now let's look at number 16. 4 less than a number. 4 less than a number. Less than, once again, is subtraction. Look at this, it's sort of written in reverse order. What are we starting with? We're starting with some number, which we'll call n. I'll probably end up using x a lot for that because I've gotten so used to using x as a general variable, but it doesn't matter, it can be x, b, q, r, z, n, whatever you want it to be. So we want to have 4 less than this starting number. Less than is subtraction, n minus 4. If you say 4 minus n, that is absolutely incorrect because subtraction is not commutative. That's not what this problem says. This says 4 less than a number. Now, let's look on page 21. Raymond earns $85. How much money will he have if, number 26, if he spends $13, okay? He started out with $85. And we want to find out how much money he's going to have if he spends, what did I say, $13. What happens when you spend money? The amount in your pocket decreases, it goes down. It's subtraction. So how much does he have if he spends $13? That's a subtraction problem. He's going to have $72. What about, this says he earned $85. This is what he's starting with. What if he gives some money to a missionary? And problem 30 says he gives T dollars to a missionary. What's he doing? He's giving something away. If you give something away, your amount decreases. How much is he giving away? $2? $5? $75? All of it? Well, we don't know what it is, but we know that he is giving away some amount of money that they call T. So this is how much money he has left after he's given his money to the missionary. That's the end of all I'm going to take time for now. Do your homework, get stuck, give me a call. Y'all are doing great. I'll see you next time.